Hey guys, Arvel from Pixel Party here, and today I'd like to show you a new tool that will allow you to take incoming audio and automate and animate your entire composition off of it. What's happening, guys? Today I'd like to introduce you to Beat Doctor. What Beat Doctor does is it takes your incoming audio, breaks it up into its individual frequency spectrums, and then it also processes it and then spits it out via OSC and DMX. Beat Doctor started out back in early 2017 as an inside joke between me and some of my touring friends. And it later developed into an actual application out of necessity. That application looks like this guy. We would find ourselves working 16-hour days for festivals 3 days in a row without relief. No bathroom at front of house, no catering being brought to you, so you're basically dehydrating out in the sun for 16 hours running visuals for people. And we said, man, it'd sure be nice if we could just use the bathroom, or maybe, I don't know, crazy idea, get some food. So I built this thing to kind of animate some parameters where we could slip away for about 10 minutes, use the bathroom, grab some food, maybe a couple snack packs, and then head back to front of house to get back at it. And since then, it's kind of evolved and grown into what we have today. So this is one of the first things I've ever actually developed or wrote, so it has a little bit of history going with me. I'm kind of proud of how it's turned into what it is today. So let's dive into it. The new interface looks like this, and up at the top left we have our incoming audio gain. Below that, it breaks down the frequency spectrum where you can adjust each one of these individually. Below that, we have a bypass for the EQ above. And then from there, it filters down into your low, mid, and high section, followed by the doctor section over here. Each one of these sections has a threshold, a smoothing, a gain, and an add section, followed by the bypass, and then a real-time feedback of what your parameters are actually doing. Like anything I write, I should have this little question mark down here at the bottom right. If you click on that, anything that turns orange, if you click on it, should tell you exactly what each one of these parameters does. So if you ever get lost and don't feel like sitting through a long tutorial, feel free to click this guy and that should help you out. Down in the bottom we have our doctor, which determines the BPM of your song. And then up in the top right we have our input level, which is green right here, and our output level, which is what you affect in your EQ, and your input gain will directly affect your output. For instance, if we crank up one of these EQs by clicking and dragging, we're getting clipping, and a clipping warning does appear. If we bring these back down, you can see that the audio has been adjusted to compensate for the EQ. Alright, so let's dive into this a little bit section by section, and we'll see what each one of these parameters do. For this example, I just have some background music being played through this. I have it muted. If you want to hear what it sounds like, this is what the Beat Doctor is actually analyzing right now. So it's just kind of a loop that has a little bit of drums and bass. You can see the kick and snare should be following along with that. Alright, I'm going to turn that back off real quick. Okay. So up here we have our input gain. This takes it from 0 dB down to negative 9999 infinite. So you can see our output is off, even though we're still showing your original input waveform right there. So that's what your volume does. Below that we have a frequency band for various frequencies. So this kind of goes like from 0 to 25. Then you have a little bit of a space here, so we're going to be going from about 30 to 45, I believe, here. And then so if you're familiar with audio, there's something called a Q, where it's kind of a range. That's what these are. It's not the exact frequency of 40. It's averaging the frequencies, I believe, plus minus 5 to 15 hertz on each side of this. This is kind of a rough guesstimate of what that is. I have to go back in and get an exact number if you need it. So for instance, we have a 40 hertz band here. If you click on that, you can raise that up or down as needed, and then you should be able to see what your adjustments are actually doing in real time as you're doing that. So that's the EQ. You can do that for each one of these bands. If you're wanting to hear what you're playing, you can click on the settings, come over here, and then you can choose what audio driver, if it's going to be Audio, default, Dante, whatever it may be. And then below that you have your devices listed. Those are all your local hardware that's connected to your machine. And then above that you can turn on your audio out, so you can actually preview what your EQ is doing to the signal. If you want to do a really quick bypass, you can bypass this EQ. So for instance, if you crank that all the way up, notice it's not clipping, but as soon as I turn this bypass off, we'll be clipping again. So that's a really quick way to kind of A/B your wet dry of what you're doing on the EQ by toggling that back and forth. So once you have your input EQ and gain dialed in, this signal is then going to be handed off into 3 different bands, your low, mid, and high. Something I did forget to mention earlier, it's always important to have good audio coming in to your machine. Garbage in, garbage out. I was a long-time audio engineer before I ever got into doing anything visual related. I was a touring audio engineer for almost a decade, so it's something I'm a little bit passionate about, but it's not something I do anymore. But it's always good to have quality hardware when you can get it. So yes, this will work if you're, plugging a cell phone into your 1/8" jack on your computer. Is it recommended? That's up for you. The way I always use this is at front of house. We have our front of house audio engineer, and I politely go up to said engineer and I say, "Excuse me, sir, can I please come out of one of your matrices or your auxes?" And there's never been a time I've been told no. They've always been super friendly about that. So they'll typically run you a stereo pair of XLRs from their console back to wherever your video station is. And from there you can have whatever audio interfaces you like. I personally use the Focusrite series. Behringer has come a very long way from where they have been. But there's a lot of options out there. I prefer something that has 2 channels of XLR, and then that outputs via USB. You can do Firewire or Thunderbolt, but USB is just kind of an industry standard. So I like the Focusrite 2i2 for an example. So I'll get a stereo pair of balanced XLRs coming from our front of house audio engineer into that Focusrite box, and then in that box I will dial the gain up to where you see it clipping on the hardware, and then I dial that back probably 2 or 3 notches. I like the audio just to be turning green, maybe just a slight hint of yellow or amber on your hardware's readout. That'll ensure that your hardware is not clipping. Clipping is never a good thing, overdriving your audio signal, but it also ensures you that your signal is not too low, so I don't have to do any sort of digital boosting. From that point on, your front of house audio engineers, he knows what he's doing, or she knows what she's doing. Depends on the situation. So they'll keep a constant level coming to you. It shouldn't drop more than maybe 3 dB plus or minus. That's where having that little bit of headroom to allow for their compensation not to cause you to have any clipping. So it's always good to have, again, quality, good audio signal coming in so it can be processed, and it's not just, jumbled up garbage that's been compressed through a really bad cable and interface. So take that as a grain of salt, and we'll move on from there. All right, so now that we've gotten our audio from our EQ and it's being passed down to our 3 sections here, what I'm going to do in one of these sections is going to apply to the other 2 sections, so I'm not going to do it for every section. You're going to get the idea of what it's doing in this one, and the same principles apply to your other 2. So for this one, I'm just going to play with low. So right now we have our threshold, and what that does is Beat Doctor says at what point am I going to start processing the audio gain for the low frequencies, which I believe I have it set up from like 20 to 30 hertz all the way up to probably the 240, 250 range is where I have low set. And I think the highs kick in somewhere around like 2.3K, maybe 3.6K, and then everything else in between just falls down into your mid section. So right now you can see we're getting some pretty good responsiveness from our low channels. If I turn this threshold down, it's going to become a lot more sensitive to the audio gain coming in. As I turn this up, it's going to be less sensitive to the audio gain coming in. Think of this as a gate for any of you audio guys out there. So the lower this is, the more sensitive, so like your lower volume amplitude frequencies will have more of a dynamic range than when you have this a lot tighter up here in the end. So that's what threshold does. Below that we have our smoothness, and if we turn that all the way off, it's going to be very hard cut, on off. That gate's going to be very tight. When we turn the smoothness up, it's going to allow for it to kind of flow a little bit more. Kind of adds a bit of a lag or a delay between your highs and lows when it drops in between them. Just kind of smooths things out just a little bit. So no one wants to have, maybe you do, I don't. No one wants to have effects that's just kicking in super quick, in and out like that. You really don't get the visual impact of that effect when it's that tight, again, in my opinion. Whereas if you kind of smooth this out a little bit, it's going to, that amplitude is going to hang open just a little bit more before it slowly starts pulling back in. You still get your dynamics through that, but it's not going to be as tight. Just a little more smooth. Below that we have the gain. When we turn this down, think about turning on like an audio. You turn your volume down a bit. You're still going to get your input ratio. So if your dynamics are going from 0 to 1, you're still getting that 0 to 1, but it's only in the smaller gains range. Whereas if you turn this up, you maintain that ratio of dynamics, but it's just amplified a lot more. So from what was going, only something that's moving, maybe a fraction of an inch here, that same ratio of how far it's moving is going to get amplified to a lot larger scale. And then below that we have our add, and what that does is it even amplifies that gain even more, where if you're only going from maybe like a 0 to a 0.25 range here, as you add this up, it's really going to boost that even higher. So if you feel your lows need to have more dynamic, you want it to output higher up in the numbers, like maybe your 6 to 10 range, crank up your add, and it'll keep all of your settings above, but it just multiplies the amplitude of that. If you're wanting to use your lows for effects that maybe only has a slight bit of a bump on it, you can bring this add down, and it's going to maintain all your settings above, but it's not going to blow your outputs up into the 7 to 10 range. It's going to keep it closer to your 0 to 3 range. So if you're only wanting slight bumps, let's say you're using like a fisheye for an example, and you want it just to slowly pulse and bump, you can use this for that. Whereas if you're wanting to maybe go on a like a shift or a scale, and you want it to really pop from low to high, you can crank this up here, and it's really going to blow that that scale up a whole lot more. Below that, we have our bypass. You just hit that, and it just completely bypasses your low channel from the output. So these principles apply to your mids and highs as well. Moving on, we'll go on to the doctor section of everything. So the doctor section has specific frequency ranges that listens for that what it would consider a kick drum, a snare drum, or maybe a rhythm section. And just like we discussed up here with your threshold, you have a threshold for your kick, snare, and rhythm as well. The higher up this threshold is, the tighter the gate is going to be, so it's not going to recognize some of the lighter, softer touches. And then the lower it is, the looser that gate's going to be, and then any sort of like low noise floor is going to come through as potentially being seen as a trigger for the kick channel. So it's good to kind of set this to where you see your kick pulsing like it would normally in the song. It's not hanging open too long, and it's not missing any triggers at the same time. And this may need to be something that needs to be changed for each song. Typically, I find it artists usually play 3 or 4 songs with the same style where it kind of flows into each other. So it's something I don't have to adjust a whole lot, but definitely if you're going from a very loud, high dynamic song to maybe a slower melodic one, you'll need to change that up a bit to compensate between the two. So right now we have a nice steady little kick going right here. And then over here at the very bottom left, we have our BPM input. And that is what channel the Beat Doctor is using to determine what the BPM is. Right now we have it set to kick, so anytime the kick is triggering, the Beat Doctor is also triggering. If we move that to snare, now whenever the snare is going, it's using that as its input to determine the BPM. You can get a lot of false positives, or it's not really an exact science, or it is a science, but the way it works is you're basically measuring the time between each beat to determine what the BPM is. The problem, though, is if you get like a false trigger, that's going to jump that number up quite a bit because it read something that was not intended to be the beat. So I have a system in place where it's basically caching 10 seconds worth of beats, and then it's using the I'm going to get this wrong. I want to say it's the mode, like the mean median mode. The number that shows up the most out of those 10 seconds is what it determines the beat is. And each one of those, there's a section for each second, if you want to put it that way. Each one of those is getting overwritten as time goes on. So it should be updating in real time, and it may take up to 4 or 5 seconds for everything to average out if you're going from something super fast down to maybe a little slower, because it's still caching everything from the previous time in there. So your BPM response may not be exact as it changes, but on the flip side of that, you're not getting a ton of these false positive readings, and your BPM is just not throwing itself all over the map, where it's 16 different BPMs in a matter of 4 seconds, because that's not realistic. So if you don't see your little orange feedback going here, that means there's been too much of a break in between the beats, and it's taking a few seconds to kind of get its bearings back. It's filtering out all the older caches and updating the newer caches as it comes in, and as that gets updated, it should push down to your BPM in real time. This application is not designed to spit out BPM in real time. It can do it. I do not recommend it. So this is set to kind of like a push only. So whenever you hit push, at that point it'll push that BPM out into Resolume. And if we go into our settings over here, we have a OSC in push address. So right now I have our composition resync button also pushing into our beat doctor to send out our BPM push. And then you can map, a MIDI controller to that button, however you want to go about doing that. So whenever I hit resync, notice right now we're on 90, and if I hit resync, it should jump up to 134, which is not right. Should be closer to 122 for this. There we are, 120. The way around it, if you wanted this to be a constant change, you can just find a way to latch whatever button. If you want to assign it to a slider and turn that slider all the way to 1, it's going to hold open that channel, and it's going to be the same thing as holding that push button down. So for instance, if I click and hold on resync here, you're going to notice that the BPM in Resolume is changing in real time as the beat doctor changes. But again, the song's not 97, so I don't want to push out something that's going 98, 97 when I know it's going to be closer to 122, 123. And this is where really dialing in your settings, making everything super tight, taking a little bit of time to set it up will go a long way. If we go to our Resolume sources, I do have the BPM of this app coming out via Spout and NDI. And if you're not aware, this is ran through Touch Designer. In order for NDI to work, you need a pro or commercial license of Touch Player or Touch Designer. If you don't have that, don't worry, Spout still works, and you'll be just fine using that. So here's our source right here. And you can see down here at the bottom, it's updating the BPM in real time. The background will flash every time that the beat doctor detects a beat. So this is kind of how I play with it. I usually just have this thing always on in my preview down here, and when I see the background flashing in real time to the song, if this is flashing at the same time that the beat's hitting and the number's pretty constant, at that point I'll come through here and hit resync, and we're all good. I don't have to tap out the song 10 or 12 taps in a row. I just kind of keep an eye on this, and whenever it looks like it's right down here, at that point I'll push it through, and that'll update the BPM in Resolume. Alright, so I'm going to go ahead and play with a few examples here. I'm going to go ahead and turn the audio back on so we can hear what's happening while we're actually adjusting some settings. So by turning audio on here, I can now hear it in my speakers. I'm going to adjust the Resolume BPM down to 90. I have these clips set to BPM sync, so as you can see right now, the clips and the audio are not lining up. If you're watching the BPM ticker down here and you're listening to the audio, it's not the same. But I'm looking at my background right here flashing, and that's flashing at the same time that the beat is hitting on the song. So if I hit resync on this, now if I look at the video clips, the clips are going in the same time as the beat. And for this example, I've also animated some effects on top of that. going to turn the audio back off real quick. Alright, so now that we've gone over the user interface for the Beat Doctor itself right here, let's dive into some of the settings and see how we can get this pushed out to Resolume and other applications. If you click Settings down on the bottom, it'll take you into the settings screen. And up at the very top, we have our OSC assignments. We have a OSC monitor and a DMX monitor. So for the OSC assignments, we can assign OSC outputs for each one of the frequency bands. We can also output low, mid, high. We can output the kick, snare, and rhythm. Then I have an RMS section, which is just your overall amplitude of the audio signal. So however loud your audio is for that song overall, that's what RMS is. So how do we start assigning stuff to this? Let's look at this effect up here. We have this clip up here, some effects on it. I got this awesome color changing app called Tritone from Subpixels. Big fan of this app. If you haven't played with that, definitely highly recommend getting that a download. What I'm wanting to do is change these whites to a different color. So we have our white tone right here, and what I'm wanting to do on this is perhaps drop the greens. I'm going to bypass all my other effects really quick. There we go. So that's a big difference going from that to that. That's pretty cool. But I want it to do it with the audio. So what I need to do is we'll go to our shortcuts in Resolume. I'm going to click on the green channel right here. I now have my OSC assignment for that. And I have, on OSC, I have output all OSC messages turned on. So Resolume's always outputting everything via OSC. And then I go also into my OSC within Resolume here, and I make sure that my input and output is turned on, and I have my ports set up. Going back into Beat Doctor, down here we have our OSC import, our OSC output. Those match the ports in Resolume. And down here at the bottom we have OSC and DMX turned on, so Beat Doctor is now outputting OSC and DMX. At any point I'm getting some weird behavior, I can always come in here and quickly turn these off, and then things just react normally as if this wasn't running. Alright, so I copied the OSC parameter for the green channel on this, and I want this to go in beat. So what I can do next is hit my OSC monitor, and I'm getting a real-time readout of what OSC is sending for each one of these frequencies. I think I'll just use the kick detection right down here. So that means I will click on kick. I'm going to go back to our OSC assignments, and I'm going to change the amount of outputs from 0 to 1. I'm going to come right here and paste that in, and looky there. We're now pulsing color in beats with the audio. Each one of these channel outputs can have a maximum of 128 outputs per channel. My math's not good. Let's see what that is. 128. I think there's 23 total channels. Yeah, that's like 3,000 OSC outputs. I'd hope you're not using that many. It's probably going to slow your system down a lot, but it can do it. Alright, cool. So we have our kick changing colors in real time with the audio. And if we come down here back to our kick and we turn that threshold up quite a bit, you can see it's not changing over here. And then as we turn that on, you can see now that's always, not always on, but it's on more than it's off, and the effect is white. And as we dial this kind of back into the little sweet spot where it was, as that is pulsing, our colors are pulsing with it. So whatever you affect here directly affects your output. If you want more lows, you can crank up that low add, and now your output for that low channel is going to be a lot higher than it was if you had that down low. Alright, going back to our assignments, we have some color going on. That's cool. Let's move on to some other effects. Next we got a hue rotate. I got this little envelope set up on it. And let's go back to our OSC monitor and let's see what's kind of pulsing on. I'm going to do the 150 Hertz channel next. So we'll click on the 150 Hertz, go back to our OSC, change our output number to 1. You can scale this up to 10 if you want to, however many you want. You do 100, there's 100. We're just going to do 1. I'm going to come back to Resolume. I'm going to go to my shortcuts, and I want to hue rotate. I'm going to copy that shortcut, and I'm going to paste it right here. I'm going to unbypass the effect. As you can see, we're getting this awful looking rainbow color effect. At the top here of our OSC screen, we have some advanced features for our outputs. So right now, our filter's turned off. So if we go back to our OSC monitor, here's what we just pasted in. This is the hue rotate, and going from 0 to 100, we're going about to 0 to 50, 0 to 30, somewhere in that range is what we're outputting, and you can see what it's doing here in real time. What I'm wanting this effect to do is, rather than follow the exact audio of this, I'm going to turn a filter on. And what I can do is, over here is your threshold. So as you can see, we have a constant source of audio coming in. If I crank this threshold up a little bit, this operates the same way as all the other thresholds in this application does. So right now, it's pulsing with the beat. That's pretty good. And when we have it set to audio mode, what it does is whenever this is turned on, it's going to use whatever value that your audio is seeing. So in this case, 150 Hertz is going anywhere between like 20 and 30. So whenever that's turned on, it's going to follow whatever number the amplitude of that audio frequency is. If we don't want it to be 0 when it's off, we can crank that off value up, and as you can kind of see down here, this is moving with this slider right here. So let's say we want the hue to be, 57% when it's off, and then whenever it turns on, we want it to go to wherever the audio level currently is at. So that takes us from like a darker green more to like a lime green. Next, we can change that to custom, and at this point it's no longer following the audio at all. What it's doing is when it's off, it's set to your off value, and when that is turned on, it's to your on value. So we can change this from like maybe 0.53 to like a 0.63. As we change this up, we're going from like a green to a red. The next thing we can do is the hold mode, and what hold does is there's a timer running constantly, 0 to 1, 0 to 1, just keeps repeating. Whenever this is turned on, it turns the playhead of the timer on, and when it's turned off, it pauses the timer. So this is a cool way where you can kind of have this play through as if it was playing on a timeline mode. If we were to come to hue rotate, put that on timeline, see how it's kind of moving forward like that. We're going to have the same system in place, but the audio is going to drive when that's being played. So by putting this on hold, you can see anytime that turns on, it's slowly progressing forward the position. And we're slowly getting through our hue range, and then it just repeats again. So as the audio comes on, it's slowly making its way through the different channels of the hue. So that's what the filters at the top do. We have a hold, custom, and an audio. And if you just want it to be completely driven off audio, no filters at all, just turn off your filter, and there you have it. And at this point, it's just using audio to drive it. One last thing to mention on that is if you actually click on this indicator, it's going to turn on this red little square around that, and that's going to add a little bit of a lag or a delay to your fall off. So if you're looking at this, you can kind of see how nice and slow that. There's not going to be any delay from when it actually attacks. Think of it as a release if you're familiar with compressors and gates. So your attack's always going to be set to the fastest, where it's always going to your on value as quickly as possible. But this has, I believe it's like a 10th or 100th of a second bit of a lag or delay on the release. So it's a little more smooth and not so harsh when it comes down. If you turn that off, you can see how quickly that's going on and off right there. It's very quick. If we turn this back on, it has a little bit of a slow delay on the way down. Gives it a little bit more of a smooth look going in between things. So that's how you toggle the declining audio. The decay of the audio is lagged a bit by clicking that. One thing to note, all the filter settings up top are universal or global for that entire channel's output. So if you have 12 channels here, all 12 of these channels are going to be using the same settings here on top. Alright, so now that we have these two effects set up, let's just do one more for this effect chain. We'll do a shift RGB, and I'm going to shift the red channel. So again, I'm going to go to our OSC output assignments, click on my red channel, copy that address. I'm going to go to my OSC monitor. I kind of go to the OSC monitor as a reference to kind of see what my values are at. For each song, it may be different. I want to find stuff that's actually doing some stuff. So I'm just going to do RMS on this one. It's getting a pretty good set of movement going on. So I'm going to click on RMS, go back to my OSC. I'm going to add a channel. And as you can see here, we are now shifting, we're zooming the red channel out a whole lot right there, which is not what I'm wanting. So I'm going to turn on my filter. I'm going to go to custom, and I want my start point of this to be at 0.05, which is halfway. I want to adjust my threshold here so it only kicks on occasionally. And then I want my on value to be like a 0.6. Actually, that needs to be a lot smaller than that. Let's go like 0.55. And there you can kind of see it is now shifting the RGB in sync with the audio as well. If we bypass that effect, That's what it looks like without it. And then with it, we are getting that. So to kind of sum up, just, using 3 effects here, which isn't much. I mean, you can pretty much automate your entire composition off this if you wanted. We went from having this clip right here to kind of having that, and it all syncs up with the audio. So if we change songs or something goes on, everything's going to go with it. The only thing we'd have to change at that point is the BPM of the song. But if your video clips are driven from timeline and not BPM, at that point everything rolls over nice and seamlessly to follow the amplitude of the song for each of the audio frequencies. Lastly, up here at the top we have our DMX monitor, and then down here we have our OSC in port, our push ports, OSC out, and then from here you can assign your OSC net, subnet, universe, and start channel. So all of these frequencies here are also being sent out in real time to the following DMX channels. If you wanted to start or offset starting at 10 at this point, DMX 10 starting, these are all blank. But yeah, from here you can take these values inside of your DMX console and then reassign them how you want once you have that going into your console. Below that we have our output boost. So going back to our OSC monitor, we can see right here that, for instance, like our 24 hertz, we're getting like 1 to 7, 1 to 8. It's not doing much, which is fine because there's not much going on in that frequency. So let's say we wanted to boost that number just a bit. How would we do that? Well, how I recommend doing it is going back to your settings, finding that frequency here, and maybe boosting it up a bit like that. Going back into settings, and now we're getting closer to the 20 and 30 range. But if you find yourself doing that and your EQ's looking like that, there'd be a quicker way to do that. Either turning your input gain up on your audio device, or if you need to really quickly, you can come down here to the audio boost and you can boost this up as well, and that's, so you can see, boosting everything up. It does have a limiter set on it, so you're never going to exceed 100, but at this point you pretty much just lost all dynamics because it's just going between like 90 and 100. So use that sparingly, but it is a quick way to boost your overall global output of your OSC and DMX. You can also control this remotely as well, just as if you were to hit resync on Resolume to resync the BPM. You can put in a OSC and output boost address. This one, I just have it default to like the composition link 1. So if I was to come back to effects, throw in maybe a dummy effect on this, let's go, I don't know, like vignette, bypass it, set the opacity to dashboard, and at this point you can kind of see dashboard link 1 is now affecting the overall boost of that, which is kind of nice because at this point you can just minimize your app. You can watch your BPM right here, and if your effects aren't looking as nice as you'd like them to, you just come back here, you can boost that up, and it should bring out more output from Beat Doctor going into Resolume. That's just a quick way just to have that mapped to like a MIDI controller knob somewhere where you can have that as your overall output. It'd be similar to having a master in Resolume right there. So that is an option. Below that we have your audio in. Just like we were discussing earlier with your audio out, you have your driver, have your devices. If it's 41 or 48, you can completely just turn it off altogether. Below that we have our buffers. I recommend keeping these at 0.1. The lower you have that number, the less latency you'll have, but it also degrades your audio quality a bit as well. The higher the number, the more latency, but your audio is going to be a lot cleaner in the process. Leaving your in and out buffer at 0.1 seems to be a pretty good point where I like to keep it. Then you also have your audio out. You can turn on and off, and you have the level of how loud you want your preview to be. At the very bottom, we have OSC out BPM push. By default, whenever you hit push here, it's always going to send it to Resolume's BPM down here. If you have another application that can also follow along with that, you can assign it to a separate address, and that can go to another application by assigning the address down here. Below that, we have our frames per second monitor, your GPU and CPU memory usage, local BPM clock that tells you what BeatDoctor's BPM is, save. We already discussed earlier settings, DMX on and off, and again we have the handy little help button that will allow you to get information on every one of these little settings right here. If it's orange, you should be able to click it and it should tell you what it does. Well, alright guys, that is BeatDoctor. Thanks for bearing with me on this long tutorial. If you have any questions or comments, please feel welcome to reach out to me anytime you need. Pixelparty.us or support@pixelparty.us. You guys have a good one. Cheers.